Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, it doesn't seem possible, but it's already August. The summer is flying by, and we have big plans for August here at Horner because August is IEC month. And there happens to be 5 Tuesdays in August, which means every Tuesday we've got a different IEC-related topic to cover with you this month. So why IEC, you might ask? Well, IEC programming is becoming more and more popular. It's always been popular in Europe, and we've had for some time a very loyal group of IEC programmers using the Horner products and the Horner OCS with Cscape. And we've noticed we really need to beef up our IEC content a little bit on this channel, not only for those folks who are IEC users, but for those looking at IEC for the future. Now, specifically, the topic we're covering this month is creating user-defined function blocks in Cscape's IEC editor. And of course, user-defined function blocks we cover a lot in this channel because of their importance. They're one of the best tools in the toolbox of an application engineer. But we need to give more information regarding how UDFBs and IEC work because there are some slight differences there. Now, to talk about all things IEC, let's bring in our product manager, Mr. Casey Gardner. How you doing today, Casey?
Hey, not bad. How's it going, Chuck?
It's going great. Now, I've noticed that really, over the years, Horner is one of the few manufacturers that offers choices when it comes to programming languages and programming styles. Why is that?
Sure. I think a lot of our reasoning for it is flexibility, first and foremost. While we've had our advanced ladder programming available for quite a while, and really our IEC programming as well, for that matter, it's not everybody's first choice for programming. I mean, ladder logic's been prevalent in North America for quite a while and all over the world, but ultimately more and more text-based programming or more and more other language styles are used by anybody and everybody. So that's one of the main goals or accomplishments of the IEC standard, is having a lot of that flexibility, as well as even coming from other software packages that use IEC standards can allow some of that familiarity to come across and bring users up to speed a little easier as well.
Absolutely. And certainly, for instance, structured text is one of the most portable languages that are available in the IEC package, for sure. Even though it's maybe one of the more difficult packages to debug from an end user standpoint, not from an engineering standpoint, from an end user standpoint. Now, August is IEC month, but we have something big going on in September with IEC as well. What's that?
Sure. So we've got our first IEC training class here at the factory. So again, we've supported IEC for a number of years now, but as you mentioned earlier, in terms of overall content and training, we've probably lacked a little bit more in that department. So we're definitely wanting to help offer and support that content as well as we can. So that starts with training right here.
Excellent. Yeah, so we've had training courses in Europe and at distributors and partners across the world, but this will be our first factory IEC class. Okay, so while I'm presenting the material today, Casey will be standing by to answer any questions you may have in the chat section. If you're watching this on replay, like a lot of you do, we'd love to see your comments and questions in the comment section, and we'll get back to you just as soon as we can. All right, let's take a look at how we're breaking down today's topic. Okay, so we're going to do a very quick review of user-defined function blocks, and then we're really going to focus on user-defined function blocks, creating them and using them using the different IEC-based languages. And today there's going to be a few slides, but really it's mostly going to be about the demonstrations, which is always a good thing. Okay, so what are user-defined function blocks? Here's our quick review. Well, basically these are sections of code that can be modularized into a function block by the programmer, not a function block that was chosen by a Horner engineer or by an IEC panel, but a function block customized by a programmer deciding what function he's looking for, what code will reside in that function, so he can use it on his programs over and over again. And one thing that separates UDFBs from subroutines is that they have their own dedicated variables. So if you have multiple instances of a user-defined function block, each instance has its own dedicated set of input, output, and internal variables, which is a capability you just don't get with subroutines. And then once created, user-defined function blocks can be used multiple times in a single project, and they can be imported into any future Cscape project. So there's a lot of real advantages to that particular capability. Now, from a basic UDFB workflow, how do you create user-defined function blocks? Well, the first step is always to isolate the logic that you're going to turn into a function block. So whether that's writing it from scratch, whether that's extracting it from an earlier program, you need to isolate that logic and really test the heck out of it just to make sure it's doing exactly what you want and that it's the data you're going to need or the code you're going to need to create the function block from. Once you've got that where you want it, now it's time to take a look at the inputs and the outputs to come up with a list of variables to be used as inputs and outputs for the function block. And then the other variables involved that aren't inputs and outputs, they'll end up being internal or private variables used by the UDFB, but not necessarily accessible from the outside world or from the rest of the program. Then once you've established that, you're going to create a new program, go to the Cscape Navigator, add a new UDFB, give it a name, and then as soon as you give it a name, you're going to find that in your program variable window, there's going to be a new section that shows up under the UDFB name. And that's where you can enter in the variables that you need, inputs, outputs, private variables. And then once that's complete, it's a matter of taking that code that you've created and isolated and tested and copying and pasting it into the logic area of the UDFB, or you can put it in there manually if it's relatively small. Once you've done that, it's of course a matter of finishing your testing and ultimately exporting the UDFB, importing into another project, and just verifying it with multiple instances. So it looks like quite a process, but the reality is the end result of that is a piece of code that's well tested, that saves you time and saves you programming errors in the future, and you should really take advantage of it as best you can. Okay, now let's talk about some of the differences when you're using and creating user-defined function blocks in our IEC editor versus our variable-based advanced ladder editor. Let's start with variable name. So in variable-based advanced ladder, you're going to go through that same workflow that I just described. That part doesn't really vary any. But the variable names that are used inside the UDFB for variable-based advanced ladder, they use the UDFB name as a prefix. So let's say you've got a UDFB named convert and you have a variable named enable. Well, in variable-based advanced ladder, that variable name effectively is going to be called convert.enable. That's just the way it's going to be nomenclated, if you will. In IEC, there is no prefix. So an enable variable is just enable. Now, the only negative to that is you don't have the ability to use another variable name with the same name, like enable, elsewhere in your program. There will be a conflict. So that's why it's a little different in IEC versus VBAL in terms of the naming convention. Now, in terms of compatibility, also realize that you can't, just like you can't take a Cscape logic file that was created in IEC and use it in variable-based advanced ladder, the same is true for the UDFBs. So UDFBs in variable-based advanced ladder have a CPU extension, and those in IEC have an XK5 extension, and the file format is also different, so they're not interchangeable. And then finally, from a logic visibility standpoint, in variable-based advanced ladder, you have the option when you create a UDFB, when you export it at that step, to hide all the logic inside the block. In IEC, that's not an option, so that's another difference I wanted to point out. Now, the languages that are available for the creating and use of user-defined function blocks are the same 4 languages throughout, and they include 3 of the most popular. So ladder logic, function block diagram, and structured text. Now, instruction list also can be used, but the reality is it's not a very popular language anymore. Now, the one language that is missing, you'll notice, is sequential function chart. That one is not up there because it's not conducive to using user-defined function blocks. Okay, so now we're going to dive right in to the demonstration portion of our program, which is pretty much going to take up the rest of our time. So let's go ahead and get started in Cscape. Okay. And what I have here is an extremely simple application. I really wanted to focus on the mechanics of creating and using UDFBs as opposed to creating any kind of highly useful UDFB that everybody would want to use. So what I've decided to do here is I've created some simple logic in 3 different languages, in ladder, in function block diagram, and in structured text. And all this logic does is effectively convert a value that's a floating point value from degrees Celsius to degrees Fahrenheit. So extremely simple. Again, the whole idea is to show the mechanics of creation and using of UDFBs. So in this rung, we're talking about a single rung here. Now, of course, UDFBs can contain a whole length of rungs. It can be a number of rungs. Doesn't have to be this simple, of course. But again, I'm just showing the mechanics. So in terms of creating a UDFB, what do we need to do? Well, the first step, of course, is isolating the logic, writing the logic, and testing it. We've done that. Okay, the next step is establishing the input variables, the output variables, and any internal variables. So for this scenario, we have one input variable to the function block when it becomes a function block, and that's the original value in degrees Celsius. Then we're going to have one output variable, which is the converted variable floating point in degrees Fahrenheit. And in the case of ladder, we also need the scratch pad internal floating point variable that we can use for the intermediate value in between the multiplication and the addition. So that's really what we're talking about here. One input, one output, and one internal for this very simple case. All right, so the first step, of course, is to test and make sure everything works properly. And of course, we've done that. Let me go ahead and just show you my bench here. And you'll notice that, with a value of 0C, I'm getting 32F. And with a value of 100C, which is the boiling point of water, I get 212F, which matches as it should. So as you can see, we've thoroughly tested the logic and it's working as it should. All right, so now what I'm going to do is I always like to create a new program that actually is used in the creation of the UDFB. So I'm going to do File, New. I'm going to create an IEC program because I'm creating an IEC user-defined function block here. Okay. And once that's open, I'm actually going to start by going into, let me go ahead and minimize that program and let me get this one spread out here. So I'm going to go into the control area under logic modules, and under UDFB modules, I'm going to right click and say new UDFB block. Now in IEC, you've got your choice of 4 different languages to create the user-defined function block, and you can create them in any of these 4. My example right now is using ladder. So let me create ladder here. This is where I give it a name. So let's say that we're just going to call this degrees C to degrees F. That's what we're going to call it. All right, that's going to be the name of our user-defined function block. And then the next step is for us to create the variables we need in order to use this UDFB. So you'll notice down here, a new section in our program variable window is created, and we can go ahead and start adding variables to this. And if you remember, we have one input variable, which is input value. Okay, and that is a real value, not a Boolean. We have another variable to add, and that is the output variable or output parameter. And of course, you can have multiple input parameters and multiple output parameters. And let's call this one degrees Fahrenheit, or let's do it this way, output degrees Fahrenheit. There we go. Once again, this is floating point. And then finally, let's add a final variable. That'll be our internal variable or private variable. Again, a floating point value. And this one will be called scratchpad. Okay, so those are the variables we need to add. I've got those added. Now it's a matter of adding in the logic that I need to actually, inside this function, to do the work. So I'm going to go back to my original program, to the code that I tested thoroughly. I'm going to go ahead and just copy everything, including the comment. Don't have to copy the comment, of course. Go into my new program in my new user-defined function block area, hit Control-V to paste, and now the logic is in there. Now, at this stage, this is the stage in variable-based advanced ladder where we would go through and add the the UDFB name as a prefix to all of our variables. We're not going to do that here because we don't need to, but we will take the time to verify that we got the names exactly right. So input value, scratch pad, output degrees F, output degrees F. Okay, so that all looks good. All right, so we've created a user-defined function block here named deg-C to deg-F, and now it's a matter of testing it out. So let's go into the main loop of this same program, okay, and let's create a new main loop module, and let's go ahead and create a new ladder logic block. Now, we could actually use this UDFB in any of these languages, except for SFC, of course, but we're going to go ahead and stick with ladder for now, and then we'll show you how to use this in other languages a little bit later in the demonstration. Okay, so how do I drop my user-defined function block in here? Well, let's say this is a function block main loop module that we're going to call temp control. Okay, so maybe we're doing temperature control. And we want to do a variety of things, including doing some conversion between degrees C and degrees F. Well, the function block I want to drop on here is now listed at the bottom of my toolbox under project. You'll see that UDFB listed right there. So I can just drag it right there to the beginning of my program, stretch it out a little bit so I can read it a little easier. And there it is. There's our degrees C to degrees F user-defined function block. And if I double-click here, I can name this instance of the function block. So remember, we can use multiple instances of this. So let's say that we're just going to call this temp1 convert here, okay? And it's of the type degrees C to degrees F because it's an instance of our UDFB. So we'll say yes there. And now we just need to configure the input variable and the output variable, and we should be done. Okay, so on the input variable side, maybe what we have here is an oven temperature, and maybe that oven temp, we're getting it in degrees C. Okay, and we're creating this on the fly right now. So real looks right. And then let's also configure our output variable. And this type, maybe it's oven temp degrees F is what we want to call this. And again, it's a new variable because I hadn't previously created it. It's again floating point, and away we go. So that's really all there is to using the user-defined function block here in IEC. Really straightforward. As you can see, everything's pretty much ready to go. Now, one thing I will do is I'm going to go ahead and do an error check. And basically, it's telling me everything looks good. Now, this non-fatal error basically is just saying, hey, you haven't created any screens yet. Are you wanting to continue or not? So I'll say, no, that's okay. I'm not getting any of the type of errors that I was looking for if I'd have made a mistake up to this point. Okay, so that's what's required in terms of creating a user-defined function block and then using it as an instance in your program. Now let's go ahead and export it so that we'll be able to use that user-defined function block in other programs in the future. Okay, so I'm going to go here. I'm in my second program here. I'm going to go to the UDFB module there. I'm going to go ahead and right-click on it and say export logic module. All right, and degrees C to degrees F.xk5 is what I want. Now, I previously created this UDFB, so I'm not going to recreate it again, but it's effectively the same steps that I just demonstrated for you. Right-clicking and saying save and giving it a name. And I always name my UDFB files with the same name as what the actual UDFB has been named earlier. Okay, so I'm not going to save it again. All right, so that's what's required to effectively create and test out for the first time your UDFB. Now let's go ahead. The next thing I wanted to cover was actually using that UDFB that we've just created in different IEC languages. So just because we've created this UDFB in ladder, it doesn't mean that everywhere we use it in the future, we have to only use it in a ladder routine. We could use it in a function block diagram routine. We could use it in a structured text routine. So let's head back to Cscape. And now let's take a look at how we might utilize this same UDFB, but with other languages. Okay, so the first thing I'm going to do is I'll go ahead and get out of this program here. Normally, of course, I would save it, but I've already demonstrated this for you. And I'm going to close this program as well. We don't need this one open anymore. Okay, no sense saving that one either. And I'm going to create a brand new one. Okay, brand new IEC program. And I'm going to show you how to get started in terms of making sure that this new program can also use that user-defined function block. And the way I do that is by going to Control and going to Logic Modules and going to the Logic Modules itself and right-clicking and Import Logic Module. So that's where I'm going to import that XK5 file that I had saved in a previous step. If I archive this guy, it's going to be available on any future project I want to use it with. So now it's been imported into my project. So now if I create a new main loop module, and let's say this one, we're going to go ahead and let's say we're going to do this one in function block diagram. And let me go ahead and give a name here. I'm going to call this oven control. Very good. And I'm going to do my conversion in the oven control routine, and I'm going to use that user-defined function block that even though I wrote in ladder, I'm going to go ahead and use in function block diagram. So I'm going to go back down here to the project area, find degrees C to degrees F, drag it on my desktop, all right, and go ahead and give it a name. Let's go ahead and call this temp convert. Okay, and again, the type is of my user-defined function block, and that all looks good. And now really it's just a matter, let's slide this over a bit. Now it's just a matter of dropping some values on the screen, and let's drop that there, double click here. This is going to be the input variable for my project. So let's say this is, again, I'm creating these on the fly, oven temp deg C. All right. Got it. Oh, we don't want Boolean. We want a floating point value. So we had to pick that one manually. Let me find it. There we go. Okay. And then on the other side of this function block, that's where I'm going to need to drop this guy, oven temp deg F, let's say is what I'm naming it. And again, make sure I pick the right variable type. Okay. And then it's a matter of just hooking these guys up to the input, hooking that guy up. Oops, don't move him over. We want to hook him up to the output. And there we go. So there is our function block diagram logic utilizing a UDFB that we created in ladder. So nice. That's very flexible. And finally, let's go ahead and do something similar, but let's use structured text this time. So I'm going to create another module. Okay, that's a structured text module. And we'll call this, let's just call this one temp display. So let's say we got a routine where we're going to use to display some temperatures. So I'm going to put a comment in here, logic to convert temps from degrees C to degrees F for display, for instance. Okay, so now I need to utilize this UDFB. Now, with structured text, one thing I'm going to have to do is in a separate step, I can't just do it on the fly. In a separate step, I'm going to have to declare an instance of the UDFB. I can't just drag this guy directly on here and then rename it later. I guess technically I could, but what I prefer to do is I prefer to pull up the variable window, and I prefer to go ahead and add a variable here. Okay, so let me go to the global variables area. I will add variable, and I'm going to add a variable called, well, actually, we've already got one created. Never mind. Because this is in the same program, just elsewhere, I don't have to, actually, yes, I do. I've got to create a new instance of this guy. So I almost had a false step there. All right, so let's call this one temp display. All right, and I don't think that is a name I've used before. And the data type is going to be, the type is going to be my user-defined function block name, which is right there. There we go. All right, so now I've created this called temp display. I can reference this instance of my user-defined function block. I can reference that in my ST program. So I can call this, so what I'll do is I'll start typing temp display. And then as soon as I hit that open parenthesis, I'll get the syntax to show up. Okay, so the first thing I need to have there is my input value. I'll need to throw that in there. Okay, so let's say for the sake of argument, we've got a platen temperature. Okay, so platen temp deg C will be my input variable. Okay, and then that's actually all I will have on this line, and I'll finish up that line with a semicolon. Now, in structured text, I actually need to do this in 2 lines. So my first line was calling my function block. All right, and here is saying, hey, you haven't created this Platen temperature degrees C variable yet, which is true. So let's go ahead and get that created on the fly. Okay, so now that's created. Now in the second line, what I need to do, the output of my function block, let's say, is Platen temp degree Fahrenheit. Let's say that's what I'm getting out of that. And this is an assignment statement. So we're saying Platen temp degrees Fahrenheit equals the name of my function block is temp display dot, okay, because the syntax I need to use when I'm referencing the output is temp display, and then the output is called output deg f. Okay, so effectively what we're doing here is the input to our function, to our UDFB, is the instance name is temp display. The input is Platen temp C. The output is Platen temp F, and we're assigning Platen temp F to the output by referencing the output of the UDFB in that line there. So that is our syntax, and that should be what we need to do to get everything working for that point as well. Okay, and then the last step we would take is just really a matter of testing everything out and making sure everything is working the way we'd want. But again, because we tested this user-defined function block previously, we shouldn't have any worries about having any bugs related to that function block itself, at least not in the logic related to that function block. Okay, so that's pretty much the material that I wanted to share with you today, and I hope that has been useful. I hope you'll find that user-defined function blocks are just as outstanding of a feature in IEC as they are in variable-based advanced ladder. Okay, so as we wrap up today, remember, UDFBs are certainly one of the most powerful tools available to any applications engineer to modularize and replicate your logic in a terrific fashion. The workflow that we use to create UDFBs really doesn't vary much between IEC and variable-based advanced ladder. Yeah, some details are different, some mechanics are slightly different, but the overall process is the same. And remember, one of the great things about IEC is that you can create a UDFB in one language and utilize it in other languages down the line. So this is the portion of our program where I remind you that we're here every Tuesday at 2 o'clock with either a fully live video like today or a pre-recorded video that we're streaming live, and we always have folks standing by to answer your questions. This is the 10th year of the Horner Lighting Group. Check out their great videos on the Horner APG channel alongside our automation videos. And remember, as Casey mentioned, we've got our IEC training coming up in September. If you're interested, don't miss that. Get signed up today. And there's still a couple seats available, I believe, although it's getting pretty full, for the advanced OCS training in early August, taking place really just a week from now. So that's something to keep an eye on as well. Okay, next week, our second IEC-related topic of the month, we're going to be talking about for next and do while loops in Cscape. Summer, and that roller coaster back there looks pretty fun, although I'll be honest with you, going upside down at a high speed usually makes me dizzy, but we'll just cover the for next and do while loops next week, and I'll skip the roller coaster in advance of the program. So for those of you who have not subscribed to our channel, don't hesitate to do so. It doesn't cost a thing. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until I see you next week, let's all get out there and do us some good.